Good morning, everyone, and thank you for joining us today. In this discussion, we will explain every Wi-Fi generation, from Wi-Fi 1 to Wi-Fi 7. Have you ever plugged in a new router and just been blown away by how much faster it is? Well, it's not magic. It's a story of constant, relentless evolution. And today, we're going to dive into that story.
But before we get buried in all the technical jargon and 802.11 numbers, let's get one thing straight. The story of Wi-Fi isn't just about chasing bigger numbers on a box. The real story here, the fascinating part, is about problem solving. Each new generation of Wi-Fi was literally born to fix a specific headache that the previous one created. It's this awesome cycle of innovation meeting new demands.
So here's our game plan. We're going to start at the very beginning, the genesis of wireless. Then we'll blast through the age of speed and into the modern era of efficiency. After that, we'll take a look at the future of connectivity, and hey, stick around, because I'm also going to show you how to figure out what you're using right now on your own network. And we'll wrap it all up with the most important takeaways.
All right, let's jump right in. We're kicking things off with the genesis of wireless, and it was all about solving one simple but huge problem: the cable. Picture it, 1997. The internet is taking off, but we're all literally chained to our desks by these Ethernet cables. The mission was clear, but man, was it revolutionary. Cut the cord. Okay, so the very first standard, Wi-Fi 1, came out in '97. It gave us our first taste of wireless freedom, but let's be real, at 2 megabits per second, it was pretty slow. Then things got interesting in '99 with Wi-Fi 2. It had this split personality. You had 802.11a on the brand new 5 GHz band, super fast at 54 megabits per second, but that high-frequency signal really struggled to go through walls. On the other hand, you had 802.11b on the good old 2.4 GHz band. It had great range, but was stuck at a pokey 11 Mbps. So you had to choose speed or range. The real game changer was Wi-Fi 3, or 802.11g in 2003. It was the best of both worlds. It gave us that sweet 54 megabit speed, but on the 2.4 GHz band, which had the range we all needed. This is really the standard that made Wi-Fi a household name.
So we did it. We cut the cord. Awesome, right? But just as we were celebrating, a new problem was already showing up. We weren't just checking emails anymore. We were starting to stream videos, play games online, stuff that needed way more bandwidth. Our basic wireless connection just wasn't going to cut it. The network had to get faster, a lot faster.
And that brings us neatly into our next chapter, the age of speed. The whole game shifted. It wasn't enough to just be connected anymore. The new challenge was all about raw throughput, about pumping enough data through the air to handle all that high-definition media.
So, what was the magic trick for this era? It was a technology called MIMO. That stands for multiple input, multiple output. This came along with Wi-Fi 4, also known as 802.11n, and honestly, it completely changed the game.
So what does MIMO actually do? Well, think of it this way. Before MIMO, your router had one mouth and one ear. It could only have one data conversation at a time. With MIMO, it suddenly grew multiple mouths and ears. It can send and receive multiple streams of data all at the same time, which instantly boosts everything. Speed, reliability, you name it. And this is why a beefy router with, say, 4 antennas gives your phone, which probably only has 2, such a great connection. Those extra antennas on the router aren't just for show. They're working behind the scenes to make the signal stronger and more reliable for your phone.
Wi-Fi 4 with MIMO was a huge leap forward. We're talking speeds up to 600 megabits per second. But then in 2013, Wi-Fi 5, or 802.11ac, came along and just floored it. It took the MIMO concept and made it multi-user, so the router could talk to a few devices at once. But the really big deal was that it basically doubled and then quadrupled the width of the highway for our data. We went from small channels to these super wide 80 and even 160 megahertz channels. It's the difference between a side street and an 8-lane freeway. And it's what blew the doors open to get us into gigabit per second territory for the first time.
So now we have blazing fast Wi-Fi for our laptops and phones. Problem solved, right? Well, not quite. Because what happened next? Everything got smart. Our lights, our thermostats, our coffee makers. Suddenly dozens of gadgets were all trying to get online at the same time. Our super fast Wi-Fi highway, designed for a few fast cars, was suddenly jammed with a million tiny scooters. We had a brand new problem: congestion.
This brings us to the modern era of Wi-Fi, what we call the era of efficiency. The focus had to shift again. The name of the game wasn't just how fast can one device go, but how can we make the entire network work smoothly when it's packed with tons and tons of different devices.
And the killer app for Wi-Fi 6, or 802.11ax, is this technology with a very long name, OFDMA. Don't worry about the name, the concept is what's absolutely genius. And it's not even a brand new idea. The Wi-Fi engineers cleverly borrowed it from the 4G cellular world, where they've been masters of handling crowded networks for years.
I love this analogy because it's just perfect. Before Wi-Fi 6, your router was like a delivery truck that, for some crazy reason, only delivered one package at a time. Even if it was just a tiny update for your smart light, the whole truck had to make the trip. Super inefficient, right? With OFDMA, that same truck can now be intelligently filled with lots of small packages for all the different houses or devices on its route. It's a total game changer for efficiency and latency, especially in a smart home. Oh, and Wi-Fi 6 also introduced something called BSS coloring, which basically helps your network ignore the chatter from your neighbor's Wi-Fi, cutting down on interference.
Then came Wi-Fi 6E, and this is a really important point. 6E is not a new kind of Wi-Fi. It's the exact same Wi-Fi 6 technology, but with one huge new perk. It got its own private multi-lane superhighway, the brand new 6 GHz band. Think of it as a VIP lane where no old slow devices are allowed. It's clean, it's wide open, and it's what finally made using those massive 160 MHz channels actually practical in the real world.
Okay, this is probably one of the most critical things to remember from this entire discussion. You can go out and buy the most incredible, top-of-the-line router that exists, but your Wi-Fi speed is almost always limited by your phone, your laptop, or your smart TV. The network is only as fast as its slowest device. If you have a Wi-Fi 6 router, but your phone is Wi-Fi 5, guess what? You're getting Wi-Fi 5 speeds. The client is almost always the bottleneck.
So, we've got speed and we've got efficiency. We're done, right? Of course not. The next big thing is already here. AR, VR, cloud gaming, all this metaverse stuff. And these applications have a whole new set of demands. It's not just about being fast anymore, it's about being incredibly responsive. We're talking ultra-low latency and unbelievably reliable. A single dropped frame can ruin the entire experience.
And that sets the stage perfectly for the future of connectivity, which is all about solving for reality itself. This is the world of Wi-Fi 7. It's the newest standard, 802.11b, and it has been specifically engineered from the ground up to tackle the insane demands of these new immersive applications.
So what's under the hood of Wi-Fi 7? Well, it's pretty mind-blowing. First, they doubled the channel width again, all the way up to a massive 320 MHz. That's a huge pipe for data. They also upgraded the modulation, basically how much data you can cram into the signal, to something called 4K QAM. But the real star of the show, the signature feature, is multi-link operation, or MLO. This is the big one. It lets your phone or your VR headset connect to the router on two different bands, like 5 and 6 GHz, at the same time. It's like having two separate connections that work together, making it faster and way more resilient.
You know, when you just see the numbers on a chart like this, it really hits you. The growth has been nothing short of exponential. We went from a respectable 54 megabits per second with Wi-Fi 3 to 3,500 with Wi-Fi 5, and now a theoretical max of 46,000 megabits per second with Wi-Fi 7. I mean, the scale of that leap is just, wow. It's hard to even wrap your head around.
All right, so now that you're basically an expert on all the Wi-Fi generations, I bet you're asking, so what am I using? Let's find out. Here's a quick way you can check what's going on with your own network.
Okay, if you're on a Windows PC, this is super easy. Just press the Windows key and the R key at the same time to open the run box. Type CMD and hit Enter. That'll bring up the black command prompt window. In there, just type netshit WAN show interfaces, all one word, and press Enter. It'll spit out a bunch of info, but you're looking for one line, radio type. If it says 802.11ac, you're on Wi-Fi 5. If it says 802.11ax, you've got Wi-Fi 6 or 6E. And if you see 802.11b, well, then you're one of the first people rocking Wi-Fi 7.
Whew, okay, that was a whirlwind tour of about 25 years of Wi-Fi innovation. So let's zoom out for a second and just boil it all down. What are the key things you really need to remember from the story of Wi-Fi?
First and foremost, remember that this is a story about problem solving.
First, we solved the cable, then we solved for speed, and now we're solving for efficiency and latency. Second, keep those three landmark technologies in your head. MIMO gave us speed in Wi-Fi 4, OFDMA gave us efficiency in Wi-Fi 6, and MLO is giving us reliability in Wi-Fi 7. Third, the tech is only half the battle. Getting new radio spectra, those 5 and 6 GHz bands, was absolutely huge. And finally, I'll say it one more time because it's that important, your network is only as fast as your device.
So that leaves us with one final fun question to chew on. As we step into this crazy new era of AI and truly immersive computing, what's the next big problem? What's the challenge that Wi-Fi 8 is going to have to solve? It's a compelling question to think about as the cycle of innovation is guaranteed to continue. Thank you so much for watching. If you enjoyed this, please subscribe, like, and share, and don't forget to hit the bell for more from Tech AI and beyond.